Okay, I wanted to give you a little help on this first worksheet as we get underway with kinetics. And this is the reaction rates. All right, so what we're going to do is first off graph our concentration and time. So you can see number one says to graph the concentration of A versus time on the grid below. Now our concentration in this case, we're talking about molarity. It doesn't always have to be molarity. It could be a gas if we're talking about gases, whatnot. But in this case and most of the cases, what we will be talking about is molarity. So what we want to do to start off with, what I suggest that you do is you properly label your axes. So when it says graph the concentration of A versus time, remember that is Y versus X. It's always how it's written. So we'd have our Y and then our X. So our Y is going to be the concentration of A. Our X will be the time. I'll move that up. And that's in seconds. All right, so now what I suggest that you do is that you make each of these little boxes along the y-axis there 0.001. 0.001. All right, that's a 0. All right, and what you're going to need to do is after you make each of those boxes 0.001, you'll realize, oh, I don't have enough space. Well, go ahead and make 3 more boxes at the top there. That'll give us a good idea of what we're looking at. So simply make 3 more boxes here. We're going to extend the graph a little bit. It'll make your life a little easier if we just go by 0.001. So go ahead and do that right now. Make each of them 0.001 and go on up until you get to the last one, which if you take a look at your data table there, we want to 0.05 is where we begin, and then we're going to end at 0.012. So we want to make sure that we can fit all of those in. So that's why I said go ahead and use the divisions of 0.001, and that's along the y-axis there. Now for our time, we have 0 to 30, so it's going to be a little bit easier. If you make each of these a second, each of the boxes 1 second, you'll be in pretty good stead there. So we'll have 1 second for each box. You can break it up into 5, 10, 15, 20, 25, 30, because those are the points that we are concerned with. So go ahead and make up your graph right now. I'll wait. All right, so you should have made your graph. And now what we want to do is plot our points. All right, so go ahead and plot your points. And again, we'll take a look at it after you get done with that. All right, so after you got done plotting your points, you should get something like a curve that looks something like that. All right, I'm going to show you the real deal later, but just to give you an idea, it'll be a curve that looks similar to what I just drew on the screen there. So our second question asks us to calculate the average rate of the reaction between a given time period, 0 and 10 seconds in this case. So what we want to do is we want to get the slope of that time period. So in order to do that, you will simply go from 0 to 10. All right, then draw a line over along your x-axis there. All right, and then along your y-axis there. And what you'll do is you'll simply take, to get slope, change of y over change of x. All right, so you will take your change of x is going to be your time. So in this first one here, I can easily do time for you, which because our time is going from 0 to 10, so our final time is 10 seconds. So we're 10 minus 0. All right, and then your x's are going to be what you come up with as far as along your y-axis there. Again, I'll show you exactly what I got, but I want you to give it a try first. All right, so what that's telling us is that we are getting a certain concentration that is changing over time. So that's what you do for number 2. For number 3, you'll do the same thing. However, we're doing it at 20 to 30 seconds. So we want to see what the rate is at 20 to 30 seconds. And our rate of, it should be, if this is a reactant, it should be going down because we're using it up. And then finally, on point number 4 there, it says graphically determine the instantaneous rate when 12 is equal to, or when time is equal to 12 seconds. So what you want to do is go along your, yep, I'm at school. All right, you want to go along your x-axis there, get to the 12, move up, and then what we'll make is a point at that 12-second mark, and then you want to make a tangential line, a line that's tangent to your curve. So it'd be something like this, but better. All right, and then you'll take the slope of your tangential line. All right, so we would simply take the slope of that, and we would find out then what the instantaneous rate is for this reaction. This is all going to come into play when we start talking about differential rate laws and the integrated rate laws. Right now, when you're taking the average there, you're talking about the differentials, and then the integrated rate laws are going to be a little more specific, which we will use graphs to determine what order of a reaction that it is. All right, so don't want to overwhelm you right yet. All I want you to do is find the average and then find the instantaneous rates. All right, I'll give you a few minutes and then I'll show you my key, what I got, and we'll go over a few points there. All right, so hopefully you have something like I have on the screen here. I'll zoom in a little bit so you can see it. You see where my y-axis is labeled there by the 0.001 and how I end up a little bit off of the graph itself. That's why we added those extra squares there. And then you can see that it was slightly like a curve here. And then the answers that I got are circled over here on the right-hand side, where for number 2, what I did is I took the change of the y that I had at 10 seconds. All right, so 0 to 10 seconds, excuse me. All right, so I went up, made my point at 10 seconds, and then I had my point at 0. And then I would take the change of y, which I got in this case was 0.029 minus 0.050. And then as we said in the previous section there, that was 10 seconds, a 10-second interval. And you'll notice, I hope you do, that it's a negative number. And what I came out with was negative 0.0021 molarity per second. Now, our units are going to come in play big time when we start talking about the rate law constant a little K, a funky looking little K. All right, I'll show you what that is when we get to it. But again, units, not only because I'm a unit freak, but it will serve you well when you know the rate law units, because that'll help you determine what order of the reaction it is. So you can see I did simply the rate, the average rate. So we're taking it over a time. That's why it's average for the first one. And then the second one, I got negative 0.0005 molarity per second. All right. And that's all that S to the minus 1 is, as you hopefully know that that's 1 over second. All right, I miss you guys chattering. All right, so go ahead and chatter right now, like you're moving between classes. All right, so you got 2 and 3, and you can see the negative sign. What do you think that negative sign means? All right, if you remember what I said, it was that we're using it up. And that makes sense. As the reaction's moving along, we're using up the reactants here in this reaction. All right, so then the final one, 4, is you can see I have my tangential line. There's a couple of ways you can do that. You can take it off to the sides of your axes, which I did in the first case. And then you can also do it by just taking a slope of your tangential line within the graph itself. All right, something that would make it easy. I just picked easy numbers that I could subtract from each other in order to get it. So what I got in the first case here was when I took it to the sides of my graph, all right, which was a 30-second interval here. So that's my X value. That's how I get the 30 seconds right here. All right, and then I was subtracting. My line hit about 0.041. All right, so it's 0.041. So it would be change of Y over change of X. So we'd end up with a negative 0.014 molar per second. All right, for the instantaneous. Now I double checked myself, which is always a good idea to do. All right, and I took one that I used easy numbers to get my slope on this case. All right, so in this case, I used 0.030, and then the final point there would be 0.018. And then the time interval there was from 8 seconds to 17 seconds. So again, you could have taken different points, and that's perfectly acceptable. But I did it just to check myself, and you can see that it is relatively the exact value, 0.0013. Now, with such small molarity, negative 0.0013, with such small molarity differences, that is definitely allowable. All right, so hopefully this has helped you as far as an introduction, but I want you also to notice one other thing here, and I have it up here as a question, and it says, what does the curve tell us? And the simple answer is that rate is not constant, that our rate is changing. And that's where we're going to go on the next worksheet as we look at some empirical data and determine what the rate law is for it. Let me know if you have any questions.